Greetings and welcome, friends. Mr. Waddy here. Another fine day to learn math because this day wouldn't exist without math or could not be described accurately without math, describing the, physics of the sun and the earth and the rotation and the time measured mathematically, all sorts of wonderful things. But today we're talking about rewriting formulas and rewriting literal equations. The actual title is Rewriting Equations and Formulas. Okay? So this is 1.5 from your Big Ideas Algebra 1 textbook, by the way. BT dubs. So here we go. It says an equation that has two or more variables is called a literal. Actually, I should have highlighted this yellow and that not, but that's fine. To rewrite a literal equation, solve for one variable in terms of other variables. Okay, so this is kind of like the big idea here. We're solving for one of its variables. All right, and I won't be able to tell you x equals 2. I will only be able to tell you something like x equals 2 plus y or something like that. And that's perfectly fine for us. So we're going to, when we solve for one variable, we're going to treat all other variables as though they are numbers. Okay, so we'll just kind of use our SpongeBob imagination, and this will work just fine. So here we go, rewriting a literal equation. Literally, this is algebra. This is amazing. Literally. Okay, solve the literal equation 3y plus 4x equals 9 for y. So the variable I'm trying to get by itself is the y this time. All right, that's my target. Targeting online. So in order to get y by itself, y is currently being multiplied by 3 and added by 4x. So SADMAP, inverse operations, I've got to move this 4x away from the y. All right, so the way I would move that is subtract 4x from both sides. All right, now 4x and 9 are not like terms, so they're each going to have their own thing. So let's see, I'll have 3y equals, and I like putting my variable first, so negative 4x, and then I'll write plus 9. Okay? That'll do x. Okay, so I'm a little bit closer to getting a y by itself. I'm solving for one of the variables. A little bit closer to getting y by itself. Now y is being multiplied by 3, so what's the inverse operation? Division. So I'm going to divide both sides by 3. So I could either do this and do one big fraction. It's possible you could do this and do a couple little fractions, just every term. Terms are separated by plus or minus signs. Divided by 3, that's fine too, whichever you're going to prefer. I'll do this case right now. So let's see, the 3's cancel out. I will get y equals, I'll write this as negative 4/3 x. If I write x on the side of a fraction, by the way, that's the same as if x was in the numerator. It is not the same as if the x was in the denominator. So, but I like having this out front. This setup will actually also help us, I think in chapter 3 or 4 when we're graphing. Let's see, and plus 9 divided by 3, what's 9 divided by 3, friends? Positive 3. All right, just a little shy, it's okay. And even though I can't tell you that y is equal to a number, I can tell you what y equals in terms of the other variable, okay? So this is solved for y, right? For y. Let's alternate universe this. In a parallel dimension somewhere, you as an algebra student, you happen to be solving exactly the same problem, except we're solving for x. What? Craziness. Not that I believe in the multiverse theory. I think it's pretty absurd and not scientific. It's unobservable, friends. It's just plain unobservable. Please. So anyways, if I want to solve this for x, let's targeting. I'm now treating x as the variable that I want to isolate. X is being multiplied by 4 and added, this is positive, by 3y. So the inverse operation of this 3y, I've got to deal with the 3y before I deal with the multiply by 4. is subtracting 3y from both sides. Okay? So I'm going to get 4x equals negative 3y plus 9. So x is a little bit more by itself now, right? That's what I'm trying to do. Solve for one of the variables. Isolate one of the variables. What do I need to do to get x by itself now? It's being multiplied by 4. Thoughts? Yeah, Tyler? Divide by 4. So I could either divide this entire side by 4, perfectly legitimate, or you can divide each of the terms by 4. I think I'm going to do each of the terms. Let's see. So I'm going to get x equals, right, because those 4's canceled out. I'll write this as negative 3/4 y plus, better plus sign that, 9/4. And I've now solved that equation for x. For x. Alternative would have been x equals negative 3y plus 9 all over 4. Equally legitimate, same difference. Alternative for this one would have been y equals negative 4x plus 9 all over 3, right? Because then up here, I couldn't have reduced that 9 if I'm having it as an all over thing. So there's a couple possible ways you could write those depending on how you want to break up the division. I prefer this and this. It's going to help us out later on in future chapters. So you can, depends on which variable you solve for. Question, yeah. This 4, which over here? Okay. All right. So you're referring to this step when I subtracted 4x from both sides? Okay. So when I subtract 4x from both sides, 4x minus 4x is 0 x's. That's why right here, notice that I didn't write any x's. And over here, I had 9 minus 4x. These are not like terms, so I can't just try to subtract 4 from 9. So that's why I wrote the 4x here and then the plus 9 there, okay, or the negative 4x. So that's what I ended up doing. Those were not like terms, so I couldn't combine them as such. So that's what I ended up having to do. We're going to do some more practice with these. I know it's weird, like having to pretend that one of the variables is just a number. I know that's a little bit bizarre, but we'll get used to it. We will get used to it. Let me do one more problem here. Actually, let me zoom in a little bit. I think I want to get some more pixels in this image. Let's solve. Ooh. Here we go. So I'm going to solve. Say this said solve for y. And then over here, we'll actually do the same thing. Solve for x. Okay? So, here we go. If I want to solve for y, targeting online. And over here, I guess, oh, wait. Paste it again. Oh, and I'm so fast, so great. Here I'm going to solve for x. So, as I'm doing this problem over here, to get y by itself, it's being multiplied by 3, subtracted by x, which I'm pretending is just some number. Okay, try to pretend that. It's being subtracted by x. The inverse operation of subtraction is addition, so I'll add x to both sides. These are not like terms, but I'm going to squeeze the x in front of the 9 here. So I will have 3y equals x plus 9. And then the inverse operation of multiplying by 3 is division. I will end up with y equals, check this out how I write this. Instead of x over 3, there is an invisible 1 in front of the x. I'm going to write that as 1/3 x plus 9 divided by 3 we said earlier was 3. I'm going to agree with my past self, like so. All right, that x over 3 is equal to 1/3 x. We'll do a lot more of that over time. But I just want to get you into the routine of kind of writing the 1/3 as a coefficient here. Okay, same problem, different variable. If I'm pretending that x is my variable, x is presently being multiplied by a -1 and added to by a 3y. So in terms of SAD mapping, I've got to deal with addition before I deal with multiplication. All right, I know that's a minus sign there, but it's actually a negative symbol. All right, think about it as like subtracting 1x, right? The operation that, in terms of x's perspective, is multiplication. So let's see, to move this positive 3y, how do I move a positive 3y to the other side? What do you think? I've got to subtract it from sides. Subtract 3y. Yep. I mean, if you guys got your multicolored writing utensils, make your notes look so cool. Let's see, subtract 3y plus 9. Also, notice this minus sign is still here, okay? I do often see students forget to keep that there. We haven't done anything with that minus sign. Now, let's see. This says that the opposite of x is equal to -3y plus 9. So, therefore, the positive of x must equal positive 3y minus 9. I'm okay if you just go through and opposite everything. All right. If you want to justify that a little bit differently, you could view this as multiply this side by -1 and multiply this side by negative. And negative times a negative is positive. Negative times a negative is positive. Negative times a positive is negative. All right. Whichever way you want to justify that is fine. If you want to avoid writing that step, which I think I do, I just say, yeah, I'm just going to opposite it. Right? Good. I think I'm good, guys. I think I'm good. All right, let's look at this next example. Picks it up a notch. Oh, I've also got, okay. All right, this one is trickier. Oh my goodness, guys. Oh, wow. Problem is beast mode right here. Okay, it wants me to solve this equation for x. Does anyone notice the immediate problem here? I've got two targets. Oh man, crazy sauce, guys. Oh dear. Oh dear, 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 dear. All right, consider this. A times B plus C is equal to AB plus AC. What's this called, this concept over here? This is the distributive property. I have two x's. I have an x in each of my terms. I'm kind of like this situation, and I want to get it to be this situation. So we are going to reverse distribute. We are going to yoink, yoink. We're going to yoink and steal the x from both of those. All right, so I'm going to yoink and yoink, and I'm going to steal, I'm going to collect taxes from each of those terms in the form of x. All right, I'm undistributing. This is like such a crazy concept. I can't solve when there's two x's, but if I could rewrite it so that there's just one of them, that will be more helpful. All right, that's the tricky step. So I'm going to have x on the outside of a set of parentheses. And now I've got to figure out what goes on the inside here. Okay, so x times what would have equaled 3x? What do you think would go here? X times what would equal 3x? 3. All right. And x times what would equal plus 5xz? Watch this. I just write everything but the x. Positive 5z. Interesting. Interesting. Okay. Now, I want to solve for x. This is my target. I've just accomplished something wonderful. I now only have one x. It's way easier to solve. I'm gonna, there we go, that's cooler. The operation that's taking place to x is it's being multiplied by this thing, and we're just pretending using our imagination that this is just like a big number. Imagine this said x times 2, or 2x. I mean, you can flip it around the other way if you want. When I have x times a number, what do I do to undo that multiplication? What's the inverse? I'm going to divide both sides by this number, right? I'm going to just divide both sides by that number, and it will cancel out, right? So that's what we're going to do. Just we got to pretend, like just kind of like squint at this and pretend that this is a one big number. So I'm going to divide both sides by 3 plus 5z. This side too. It's kind of hard for me to fit it all in there. 3 plus 5d. Dividing both sides. You could throw parentheses in there if you want, but it actually doesn't need it because the fraction bar behaves as its own grouping symbol. Let's see. So over here, I would have y divided by 3 plus 5z is equal to, and notice what happened here. This cancels out with that. So what's left? Plain old x. And I like to write it from left to right when I solve for my variables. So as my last step, I'm going to just write x equals y divided by 3 plus 5d. That's a crazy problem, I know. Okay? Crazy problem. And the way I had to do it was this undistribution. Another word for that, the math language, is factor. Factor something. Or I could say factoring is the process of factoring, of finding the factor, pulling out the common factor. Okay? So that's what I did. I stole what they had in common. Going right, just like that. That's what we did when we stole it. Oh man. Wow. These guys just, they have no remorse. They just like, all right, here's a crazy problem. So we've been dealing with x's and y's. Sometimes it'll be helpful to have a formula solve for one of its variables. Okay? Crazy? Don't worry, I'll walk you through this. We've got 4 minutes. We're cool. So, targeting online. Here we go. Solve the formula for L. It would have been so much easier. Well, actually, nope. It would have been equally easier if it was solving for any of the other variables. So I'm looking for this L and this L. There's only 2 L's. This term doesn't have an L, oddly enough. The formula that we're looking at here is the surface area of a rectangular prism. All right, 2 times LW. LW is this and this. All right, so I've got 2 of those, plus 2 times LH. LH is this back wall and this front wall. I've got 2 of those, add up those areas together. And I have W times H is the side of the box, and this side of the box, I've got 2 of those. That's by the 2. So I'm adding them all up. All right? Now the problem is I can't undistribute an L from this term. It doesn't have an L for me to collect taxes from it. But I am going to yoink from these 2 terms. I'll have a little cursive L here. Here we go. So I'll have S for surface area is equal to L times parentheses. And I've got to figure out what these 2 things were made up of. And then plus 2WH. All right, because that would have been outside the parentheses. And so on the inside, L times what is 2LW? That's 2W. And L times what is 2H? Well, that's just the 2 and the H, so plus 2H. And now I'm still solving for L. So what I need to do is get this and this away from it. L is being multiplied by a number and added by a number. Which do I get rid of first? SADMAP. I've got to deal with the addition or subtraction first. So I'm going to subtract this number. We're just pretending this is a number, okay? So don't let it scare you. Minus 2WH from both sides. I'm going to actually run out of space here. I'm going to have to shift my equal sign over. So I'll have S minus WH equals L times parentheses W plus 2H. What's the inverse operation of multiplication? Division. We're just pretending this is a number. Imagine this said L times 2. Okay, I would divide both sides by that. I'm going to divide both sides by 2w plus 2h. Same over here. Dubs plus 2h. And I'll flip it around. Oh, wrong color. Flip it around, last step. L is going to equal this, right? S minus 2WH all over 2W plus 2H. Now, the benefit of rewriting a formula as one of its variables is if I knew everything else about it, I could plug in those values and solve for L anytime. All right, thanks for watching, Internet friends. Have a good day. Bye-bye.